You begin by noticing the feeling of support beneath you. The floor, the bed, the building, the soil, the stone, all of it feels solid, dependable, still. Your body trusts the ground without needing to think about it. Stillness feels like a promise the earth makes to you every day. And yet, as you rest here, the planet below you is not truly still. Not restless. Not shaking. Not dramatic. Just slowly, endlessly moving. If you could watch the earth the way you watch clouds drift across the sky, you would see motion everywhere. Entire continents slide at the pace your fingernails grow. Oceans widen by the width of a coin each year. Mountains rise grain by grain, like a long inhale held for millions of years. You are not standing on a statue. You are riding on a traveler. Let that idea arrive softly. No sudden shifts. No danger in this moment. Just motion so slow it feels like calm itself. Imagine placing a leaf on a wide, quiet river. The current carries it, but so gently you barely notice the change. The continents are like that leaf. They rest on deeper layers of warm, softened rock, and over vast ages, they drift. This motion has a name, plate tectonics, but tonight you do not need to memorize the term. Instead, you can feel it as a story. A slow choreography beneath your feet. Giant pieces of Earth's outer shell, moving in a patient dance. Long ago, people believed continents were fixed forever, anchored like roots. It made sense to think that way. A human lifetime is too short to see a continent travel. Even recorded history is only a blink compared to geological time. Movement that takes millions of years easily hides from quick observers. But the rocks remember. The oceans remember. The magnetic minerals remember. And when scientists learned how to listen, the planet's motion became visible. Picture the Earth like a warm loaf of bread fresh from the oven. The outer crust cools first, forming a thin shell. Inside, heat remains, gently circulating. The crust is not one unbroken piece. It is cracked into enormous sections, plates that fit together like a mosaic. You are resting on one of these plates now, as surely as you rest on your pillow. Your plate has a name. All plates do. Pacific. African. Eurasian. Antarctic. Names given like quiet labels on drifting rafts. They do not float on liquid lava like boats on water, that is a common myth. Instead, they rest on rock that is hot enough to bend, soft enough to flow over long spans of time. Not liquid, not solid, something in between, like very warm wax deep underground. Heat moves there. And where heat moves, material slowly circulates. You can picture it like a lava lamp glowing in a dark room. Warm material rises. Cooler material sinks. No hurry. No noise. Just circulation. Over and over. This deep motion gently nudges the plates above. You are being carried right now, though you cannot feel a thing. Your city is traveling. Your mountains are traveling. Even the quiet desert and the frozen poles are in motion. But because everything near you moves together, it feels perfectly still, the way an airplane feels still when it cruises smoothly through the night sky. Stillness, you realize, can be shared motion. If you stretch your imagination across deep time, you can watch continents gather and separate like slow dancers changing partners. Once, all major landmasses were joined into a single supercontinent. Scientists call it Pangea, all Earth's land in one embrace. Shorelines that are now separated by oceans once touched. You can trace this with your eyes on a map. South America and Africa still resemble matching edges of torn paper. Their coastlines curve toward each other like hands that remember holding. The match is not perfect, time has reshaped the edges, but the memory remains in stone layers and fossil patterns. The same ancient plants appear on continents now far apart. The same rock bands continue across oceans as if distance arrived later. The Earth keeps records, not in ink, but in layers. And the layers speak slowly. When you think of motion, you might think of speed, wind, waves, running animals, turning wheels. But geological motion is different. It is measured in centimeters per year. A pace so calm it feels almost kind. A reminder that change does not always rush. Some change whispers. Your breath is faster than continental drift. Your heartbeat is faster. Your sleep cycles are faster. The Earth is not in a hurry. It has nowhere else to be. You can let that slowness settle into you. Beneath the crust lies the mantle, a vast region of hot rock extending thousands of kilometers downward. It is solid, yet capable of flow over immense time, like frozen honey that would pour if you waited long enough. Heat from Earth's formation and from radioactive elements still warms this region. That warmth is not violent here in your imagination. It is steady, ancient, sustaining motion like a low, endless hum. Above it, the plates ride. Sometimes they move apart. Sometimes they meet. Sometimes they slide alongside one another like passing shadows. But tonight you are not at the boundary lines. Tonight you are in the calm interior, far from edges, resting on the broad center of a traveling slab of earth. Safe. Supported. Carried. You might imagine drawing a circle around your home that extends hundreds of kilometers wide, everything inside that circle moving together as one piece. Forests, rivers, roads, cities, sleeping neighborhoods, all drifting in shared direction, too slow to feel, too steady to fear. Motion without turbulence. There is comfort in knowing the Earth is alive in this way. A living planet is not fragile glass. It is resilient, self-renewing, reshaping. Mountains erode and rise again. Ocean floors are created and recycled. The surface changes, but the world endures. You are part of that endurance. The calcium in your bones was forged in ancient stars. The iron in your blood once moved through molten planetary layers. Your body is not separate from geology. You are a brief, breathing arrangement of Earth materials, temporarily aware. And the ground beneath you is not just holding you. It is journeying with you. If you listen in imagination, you can almost hear it not as sound, but as tempo. A rhythm measured in ages. A pulse counted in millions of years per beat. Tonight, you rest on a moving world, and the movement is gentle enough to be called peace. And as you grow more comfortable with the idea that even the most solid things can travel slowly, you may begin to wonder how anyone first noticed the pattern, how human eyes learn to see that distant coastlines look like they are trying to fit back together again. You begin tonight with a map in your mind. Not a busy map filled with borders and roads and names, but a quiet one, just the shapes of the continents floating in deep blue. No labels. No noise. Only form and space. Like pieces laid out on a table before a puzzle begins. You let your attention drift over the curves of the land. The bulge of South America. The inward curve of West Africa. The long sweep of North America. The angled edge of Europe. The rounded mass of Antarctica resting at the bottom like a sleeping giant. At first, it feels random. Natural shapes are often irregular, like clouds or leaves. But the longer you look, the more a soft question forms. Why do some edges seem to recognize each other? You trace the eastern coastline of South America in your imagination, the long outward curve. Then you move your attention across the Atlantic to the western coastline of Africa, and there is a matching inward curve, like a receiving shape. Not perfect. Not exact. But suggestive. Like two torn halves of thick paper that once touched. You were not the first to notice this. Long before satellites and sonar, before deep-sea drilling and magnetic surveys, observers simply looked at maps and wondered. Curiosity often begins this way, quietly, visually, almost playfully. In the early 1600s, mapmakers started improving world maps as ocean travel expanded. With better coastlines drawn, the resemblance became harder to ignore. People mentioned it in passing notes and letters. The shapes looked related. But noticing a resemblance and explaining it are different things. For a long time, the idea drifted without anchor. Then, in the early 20th century, a scientist named Alfred Wegener sat with this same visual puzzle. You can imagine him gently studying maps by lamplight, fingertips resting on paper shorelines, sensing a story trying to speak. He was not trying to start a revolution. He was trying to answer a feeling. These pieces look like they belong together. Wegener suggested something bold for his time, that continents were not fixed. That they had once been joined and later drifted apart. He called this idea continental drift. At first, many scientists resisted. Not because they were unkind, but because the mechanism, the how, was missing. Good science is careful. It asks not only what seems true, but how it could be true. Wegener had patterns, but not yet an engine. Still, the clues kept accumulating, like soft footprints leading forward. You follow those footprints now. Fossils appear, not just any fossils, but identical plant and animal fossils found on continents separated by oceans. There is a small ancient reptile called Mesosaurus. Its fossils appear in both South America and Africa. It was a freshwater creature, not built for crossing wide salty oceans. Its presence on both sides suggests those lands were once connected. You imagine this little reptile swimming in calm inland waters millions of years ago, unaware it would one day help humans understand planetary motion. Plants tell the same story. Fossilized ferns and seed plants appear across now distant continents. Their distribution forms patterns that only make sense if the lands were once joined like neighboring gardens. Rocks speak too. Mountain ranges that end at one coastline begin again across the ocean with the same age, structure, and mineral composition. It is as if a folded blanket was torn in two and separated, but the crease lines still match when you bring the pieces close. You realize something soothing about this: the Earth leaves continuity marks. It signs its work. Nothing is truly scattered without trace. Still, in Wegener's time, one question kept returning like a tide: how could continents move? What force could push something so vast? He proposed possibilities, but they were not strong enough explanations. And so his idea rested quietly for a few decades, not gone, just waiting. Science sometimes sleeps before it wakes again with better tools. You breathe slowly and picture the seafloor, once mysterious, once unseen. For most of human history, ocean depths were hidden like the backside of the moon. But in the mid-20th century, new instruments began mapping the ocean floor in detail. The results were surprising. Instead of flat, featureless plains, the seafloor held long mountain chains, underwater ridges stretching across entire oceans. You imagine them like seams on a baseball, wrapping around the globe. At these ridges, new crust forms. Melted rock rises, cools, and becomes fresh seafloor. Creation happening quietly in darkness. Even more intriguing, the rocks on the ocean floor showed magnetic patterns, like stripes frozen into them. When molten rock cools, iron minerals align with Earth's magnetic field, like tiny compass needles. Over time, Earth's magnetic field flips, north becomes south, south becomes north. These reversals are recorded in cooling rock like barcodes of time. On either side of mid-ocean ridges, the magnetic stripes mirror each other perfectly. You picture it like breathing, new crust forming at the center, moving outward evenly on both sides. A symmetrical memory. This discovery changes everything. Now there is not only evidence that continents fit, there is a process showing how plates move. The seafloor itself is being created and spreading, carrying continents along like passengers on a very slow conveyor. Continental drift grows into a stronger idea: plate tectonics. The puzzle pieces do not just look like they fit. They were once joined. You return to your quiet mental map and gently slide the continents together. Not forcing them, just allowing them to approach. The Atlantic Ocean narrows, until Africa and South America meet. North America touches Europe and Greenland. Antarctica nestles closer to the southern lands. The fit is not exact at today's shorelines because coastlines change with erosion and sea level. But when scientists match the edges of the continental shelves, the true geological borders underwater, the alignment becomes even more convincing. Like bones aligning beneath skin. There is something deeply comforting about this kind of discovery. Not loud. Not explosive. Just pattern recognized, patiently confirmed. A reminder that truth often reveals itself through gentle repetition. You realize that science is not always a shout of breakthrough. Sometimes it is a long, careful listening. And as you grow more familiar with the idea that Earth's outer layer is broken into great moving pieces, another question begins to form: if the continents are puzzle pieces, then what exactly are the pieces made of, and what are they floating on? You begin by sinking, not falling, not dropping, but gently drifting downward in your imagination. Down through the air of your room. Down past the ceiling and walls. Down through the foundation and into the ground beneath the building. Soil becomes denser, darker, cooler. Roots pass by like thin fingers. Stones appear, then solid bedrock, quiet and ancient. You keep drifting, as if gravity has softened into something friendly and slow. The deeper you go, the more you sense that Earth is not a single solid block, but a layered body like a planet made of chapters stacked one beneath another. Each layer has its own texture, its own temperature, its own role in the long story of motion. Tonight, you are visiting these layers not as a scientist with instruments, but as a calm observer with curiosity. The outermost layer is called the crust. You can think of it as Earth's skin. It is where you live, where oceans rest, where mountains rise, where cities glow at night. Compared to the size of the whole planet, the crust is very thinner, proportionally, than the peel of an apple. If Earth were the size of an apple in your hand, the crust would be thinner than the apple's skin. And yet, everything you know directly, every forest, road, animal, and cloud shadow, belongs to this delicate outer shell. But the crust is not one unbroken wrapping. It is cracked into enormous sections. You met this idea before, like puzzle pieces or rafts. Now you come closer to understand them more clearly. These sections are called tectonic plates. You can picture them as vast slabs of rigid rock, each one hundreds or thousands of kilometers across, carrying continents and ocean floors together. A plate is not just land or just ocean, often it is both, joined on the same moving platform. You are resting on one now, not a metaphorical one, but a real geological structure beneath your feet. It moves so slowly that your entire civilization rises and changes without noticing the travel. A few centimeters each year. About as fast as your hair grows. You might smile at that comparison. Something so powerful moving at such a gentle pace. Below the crust lies the upper mantle. The word mantle might sound like a cloak, and that is not a bad image. It wraps around the deeper interior of the planet. It is made of rock too, but rock under enormous pressure and heat behaves differently than rock in your hand. Here is a comforting paradox: solid rock can flow. Not like water, not like syrup. But if it is hot enough and under enough pressure, and if you give it enough time, it can slowly deform and move. Imagine a block of candle wax. Press it quickly and it resists. Warm it and wait, and it slowly bends. Deep mantle rock is like that: warm, pressured, patient. The tectonic plates, crust plus the very topmost mantle, together form what scientists call the lithosphere. You don't need to memorize the word tonight. You can just think: the rigid outer shell. Beneath that is a softer zone in the upper mantle called the asthenosphere. Again, the name is less important than the feeling. This region is not liquid, but it is more flexible, more willing to slowly flow. It is the layer that allows the plates above to move. You can imagine the lithosphere plates like wooden rafts resting on very thick, warm clay. The clay is firm, but over long time it yields. The rafts can shift, drift, and adjust. Nothing jerks. Nothing rushes. Movement here belongs to deep time. There are about a dozen major tectonic plates and several smaller ones. The Pacific Plate is the largest, mostly oceanic, stretching under a vast portion of the Pacific Ocean. The African Plate carries a continent and surrounding seafloor. The Eurasian Plate supports a huge sweep of land from Europe across Asia. The Antarctic Plate circles the southern pole like a quiet crown. Each plate has its own direction, its own pace, its own subtle path. You can imagine them like guests at a slow ballroom dance, each moving differently, yet all responding to the same deep music rising from below. Where plates meet, The interactions shape the surface world, but you will visit those edges later. Tonight you stay with the plates themselves, these great carriers of geography. It helps to clear away a common worry. Plates do not float on oceans of melted lava. The mantle is mostly solid rock. Only in certain pockets does molten material gather. The movement of plates is not like icebergs drifting in water. It is more like thick rugs sliding very slowly over a padded floor. Pressure, heat, and time make the sliding possible. You drift a little deeper in imagination and sense the temperature rising. With depth, Earth grows warmer. This heat comes from two main sources: leftover energy from the planet's formation and heat released by radioactive elements slowly decaying inside the rock. Not dangerous here in your thoughts, just steady warmth, like a banked fire deep in a hearth. This heat matters because it keeps parts of the mantle capable of slow flow. Without it, the planet would be more rigid, less dynamic, less alive in its geology. You might think of Earth not as a dead stone sphere, but as a cooling, circulating body releasing inner warmth gradually across billions of years. And on its outer shell, the plates continue their patient travel. If you could place a star in the sky directly above your location and mark your position against it, then return in 10 million years, you would find yourself thousands of kilometers away, carried by your plate's journey. No footsteps taken. No engines used. Just deep planetary motion. There is something soothing in belonging to a system so large that hurry disappears. You are not required to feel the movement. Your only task tonight is to understand it gently. To let the idea settle, stability and motion can coexist. Something can support you completely and still be traveling. Your bed moves with the building. The building moves with the ground. The ground moves with the plate. The plate moves with the currents below. The currents move with Earth's inner heat. A chain of connection all the way down. And as you rest on this traveling shell, another soft curiosity begins to glow. What is the deeper engine that keeps the mantle slowly circulating, and what kind of hidden heat keeps the plates in motion at all? You continue your gentle descent tonight, not with weight, not with pressure, but with curiosity. You pass again through the thin outer crust, through the rigid shell of plates, and into the warmer regions below the great mantle, vast and dim, stretching thousands of kilometers toward Earth's core. There is no need for fear here. This is an inner landscape of process, not peril. You are only visiting in imagination, wrapped in calm, observing from a place of safety and wonder. The first thing you notice is warmth. Not a burning heat, not flames, but a steady, ancient warmth that has never fully left the planet since its birth. Earth formed from collisions, countless rocks gathering under gravity, striking, compressing, melting. That early violence transformed into stored heat, locked inside like memory. Even now, billions of years later, some of that heat remains. The planet is slowly cooling, but very, very slowly. Slow enough that continents can travel entire oceans while the interior still glows with energy. There is a second source of warmth too, quieter, more patient. Deep inside rocks are tiny unstable atoms. Over immense spans of time, they change form in a process called radioactive decay. As they change, they release heat. Not in bursts, not in flashes, but in a long, continuous whisper of energy. You can think of it like countless microscopic candles, each one faint, but together warming the deep interior. This heat does something important. It creates motion without storms, circulation without wind. You picture a glass lava lamp glowing in a dark room. Inside, blobs of colored wax warm at the bottom, grow lighter, and rise. Near the top they cool, grow denser, and sink again. Upward, downward, over and over. No rush. No noise. Just circulation shaped by temperature. The mantle behaves in a loosely similar way, not as liquid wax, but as hot, solid rock capable of slow flow. Where mantle material becomes slightly warmer, it expands and becomes a bit more buoyant. It rises gradually. Where it cools, it contracts and sinks. This process is called convection. You do not need the word itself to rest with the idea. Warm rises. Cool sinks. A cycle forms. Convection is one of the quiet engines of the universe. It moves air in the atmosphere, water in the oceans, and on a much slower scale, rock in the mantle. Different materials, different speeds, same gentle principle. In Earth's mantle, convection currents are not neat circles like diagrams in textbooks. They are complex, branching, shifting patterns, more like slowly folding ribbons than perfect loops. But the effect is steady, heat is carried upward, cooler material settles downward, and energy is redistributed. Above this circulating mantle sits the rigid outer shell, the plates you visited in the last chapter. When mantle material rises beneath a plate, it can help lift and stretch the crust above. When it sinks, it can help pull plates along or downward at their edges. Not by grabbing them like hands, but by creating gradients of motion, subtle pushes and pulls over millions of years. You might imagine a very thick carpet resting on a floor where the padding beneath slowly shifts and swells. The carpet responds, gently sliding, wrinkling, adjusting. Not instantly. Not violently. But persistently. Heat, you realize, is not only about temperature. It is about change. Warmth invites movement. Cold encourages stillness. The balance between them creates flow. Deep inside Earth, this balance never fully settles. There is always some difference between hotter and cooler regions. And as long as that difference exists, motion continues. You drift deeper still, in imagination, toward the lower mantle, where pressure becomes immense. Rock there is squeezed so strongly that it grows denser, its minerals rearranged into tighter forms. And yet, even here, over long spans, slow convection still occurs, like thick paste folding under its own weight. Time is the secret ingredient that makes solid rock behave like fluid. A human lifetime is too short to see mantle motion directly. Even 1,000 generations would not be enough. But with instruments, models, and seismic waves, vibrations from earthquakes that travel through the planet, scientists can map these deep patterns. They can see where material is warmer, where it is cooler, where it rises, where it sinks. It is like using echoes to sense the shape of a dark cathedral. Seismic waves change speed depending on the temperature and density of the rock they cross. By measuring those changes, researchers build images of the interior, not photographs, but careful reconstructions. A kind of planetary ultrasound. And the images show something beautiful. Earth's interior is not static. It is active, structured, circulating. This circulation connects directly to the surface story you are following. Without internal heat, there would be no long-term plate motion. Without convection, the crust might have frozen into one unbroken shell long ago. No drifting continents. No opening oceans. No rising mountain chains renewed by collision. Heat keeps the geology alive. You might like the thought that warmth, so often associated with comfort and rest, is also what keeps the planet dynamically reshaping itself. The same principle that makes warm air rise in a quiet room helps move continents across the globe. Large causes can grow from gentle rules. You rest for a moment in this idea: the ground beneath you is moved, indirectly, by heat you will never feel and processes you will never see, yet they support the landscapes you know. Plains, ridges, basins, volcanoes, plateaus, all part of a slow thermal conversation between Earth's deep interior and its thin outer skin. Nothing is random. Nothing is hurried. It is a system with patience built in. Closer to the center lies the core, first the liquid outer core, then the solid inner core made mostly of iron and nickel. The outer core flows, and its motion generates Earth's magnetic field, the invisible shield that helps protect the surface from harmful cosmic radiation. Even deeper motion creates unseen protection. Movement below creates safety above. You do not need to travel further down tonight. You have come far enough to feel the source, the quiet engine room of the planet, warm and enduring. As you slowly rise again in your imagination, back through the mantle, back toward the plates, you carry a new understanding. The motion of continents is not driven from the surface. It is powered from below, by heat stored since Earth's beginning and renewed by atomic change. A deep engine, turning without sound. And as the plates glide above this hidden warmth, they eventually meet one another at their edges, and those meetings, gentle or dramatic, shape the most remarkable features of the world you see. Tonight, you travel not downward, but sideways. You remain on the great moving plates of Earth's outer shell, but now you drift toward their edges, the long, wandering boundaries where one vast slab of rock meets another. These borders are not drawn with ink. They are not straight lines. They curve and branch and wander across the planet like the seams of a well-worn garment. You approach slowly, calmly, like a traveler nearing a shoreline at dusk. From far away, a plate boundary is invisible. Forests grow across it. Cities rest on it. Snow falls without noticing. But over long spans of time, these edges are where the most meaningful reshaping happens. Not constant chaos, but constant adjustment. You can think of plate boundaries as conversation zones. Places where two enormous pieces of Earth negotiate space. There are three main ways plates meet, and each has its own quiet personality. Tonight, you visit them like landscapes of behavior. First, you come to a boundary where two plates move apart. This is called a divergent boundary, but you can imagine it more simply as a gentle parting. The plates drift away from each other at a pace slower than growing grass. As they separate, pressure from below lessens, and hot mantle material rises to fill the gap. Some of it melts and becomes magma. It cools and hardens into new rock, forming fresh crust. New surface, born from space. Much of this happens beneath the oceans, along long underwater mountain chains called mid-ocean ridges. These ridges wrap around the globe like stitched seams. There, the seafloor is continuously renewed, old crust moving outward, new crust forming at the center. You picture it like a slow zipper opening, with warm material gently rising and solidifying between the teeth. There is something soothing in that image, the planet quietly making new ground in the dark, unseen, steady as breath. Now you drift toward a second kind of meeting where plates move toward each other. This is a convergent boundary, a coming together. But even here, the behavior has variations, like different styles of greeting. Sometimes an oceanic plate meets a continental plate. Oceanic crust is denser and thinner, so when they converge, the oceanic plate usually bends and slides beneath the continental one. This process is called subduction. The word can rest lightly in your mind: sub, below, duct, to lead. One plate led beneath another. You imagine one great slab slowly bowing and descending under its neighbor, like a sheet of paper gently sliding under a book. As it sinks deeper, heat and pressure increase. Water locked in the rock lowers melting temperatures above, helping generate magma. Some of that magma rises and feeds volcanoes on the overriding plate. This is how many volcanic mountain chains form, not from sudden bursting, but from long recycling. Old crust going down. Melted material coming up. Transformation instead of destruction. Rearrangement, not ending. Other times, two continental plates meet. Continental crust is thick and buoyant, like cork compared to denser oceanic rock. When two continents converge, neither easily sinks. Instead, they press, crumple, and thicken. The crust shortens sideways and grows upward. Mountains rise this way. You can picture a thick rug pushed from both ends, folds and ridges forming as material has nowhere else to go. The Himalayas are a living example. The Indian plate continues to press into the Eurasian plate even now, lifting those peaks millimeter by millimeter each year. Mountains are not only born in violence. They are also built by persistence. Snow falls on them. Wind shapes them. But deep below, the slow pressure continues, an unfinished gesture lasting tens of millions of years. Then you come to the third style of boundary, where plates slide past one another sideways. This is called a transform boundary. You can imagine two massive rafts drifting shoulder to shoulder, moving in opposite directions or at different speeds. Their edges catch, resist, then release. Catch, resist, release. Like hands brushing as they pass. No crust is created here. No crust is destroyed. It is motion shared along a vertical seam. Stress builds gradually where rough edges lock. When the stress exceeds the friction, there is a sudden slip and the ground above may feel a jolt. But even this is not anger. It is adjustment. You can soften the idea by thinking of it as stored motion being released, like a held breath finally exhaled. The system returns to balance, and the long sliding continues. One of the most well-known transform boundaries runs through California, the San Andreas Fault, but tonight it is not a headline or hazard. It is simply an example of sideways partnership between plates. Three styles of meeting: parting, colliding, sliding. You notice something comforting: every boundary type is about relationship. Plates do not act alone. Their most creative work happens where they interact. Edges are not just limits, they are workshops. At convergent edges, mountains and volcanoes grow. At divergent edges, new crust forms. At transform edges, tension redistributes. Each boundary recycles energy and material in its own way. Nothing is wasted. Rock is reused across ages. Ocean floor is generally young in geological terms, rarely older than about 200 million years, because it is continuously created and eventually subducted. Continental crust, by contrast, can be billions of years old. Some of the ground beneath continents has survived nearly half the planet's history. You are walking on time layered into stone. You rest with that thought for a moment. Beneath your feet may lie rock older than complex life, older than forests, older than bones. Rock that has traveled across latitudes, climates, and collisions. And still it carries you easily. From above, plate boundaries trace a connected global network. If you could glow them softly, the lines would outline enormous shapes across the earth, a hidden geometry of motion. Earthquakes and volcanoes tend to cluster along these lines, not randomly, but as natural expressions of boundary behavior. Patterns again. Always patterns. Science often advances by noticing where things gather, where events prefer to happen. Clusters reveal structure. Structure reveals process. Process reveals cause. You breathe slowly and let the edges feel less like threats and more like teachers. They show you that change concentrates at interfaces where differences meet. Temperature differences drive convection. Plate differences drive boundaries. Contrast creates motion. Even in your own life, growth often happens at edges, between ideas, between stages, between ways of seeing. The planet reflects that truth in stone. And as you continue tracing these long boundaries in your mind, these scenes of motion, you begin to notice that many of them are marked by fractures and cracks, delicate lines where stress writes its signature across the crust. Tonight, you move closer to the fine lines in the stone. Not the vast plate edges you visited before, but the more delicate features within them, the fractures, breaks, and seams that run through Earth's crust like handwriting across a page. These are faults and cracks, and though their names may sound harsh, you will meet them gently. You begin with a simple image. Imagine a thick bar of chocolate held in both hands. If you bend it slowly, tiny fractures appear before the bar finally snaps. The surface gives you warning, faint lines, soft ticks, small internal rearrangements. The break is not truly sudden. It is prepared in advance by stress. Rocks behave in a similar way. Though they feel perfectly rigid in your hand, over large distances and long times they experience stress forces pushing, pulling, or sliding them. Most of the time, rock absorbs this stress through slight bending or slow deformation. But when the stress grows beyond what the rock can hold, it breaks or slips along a surface of weakness. That surface is called a fault. You can think of a fault as a seam in the crust, a place where two blocks of rock meet and have moved relative to each other. Not necessarily a gaping crack. Often the rocks remain pressed tightly together, edge against edge, like closed book pages that have shifted. Faults are not rare scratches. They can be hundreds of kilometers long and extend deep underground. Some are ancient and quiet now. Others are still active, adjusting bit by bit as plates continue their patient motion. You trace one in your imagination not as danger, but as geometry. A line where forces resolve. There are different kinds of faults, just as there are different kinds of plate boundaries. Each reflects a style of stress. When rock is pulled apart, normal faults can form. One block slides downward relative to the other. You picture a gently stretched landscape where a section settles lower, like a mattress dipping where weight has shifted. Valleys can form this way over time, not carved only by erosion, but shaped by downward motion along faults. When rock is pushed together, reverse faults or thrust faults can form. One block rides up over another. Compression shortens the crust and thickens it. This often happens near convergent plate boundaries, where mountain building is underway. Layers stack like slowly shuffled cards. Then there are strike-slip faults, sideways movers. Blocks slide past each other horizontally. You met this motion at transform plate boundaries. Here, the fault plane is like a vertical track, and the rocks glide along it in opposite directions. Sideways conversation in stone. These categories are not for memorizing tonight, only for sensing variety. Stress has styles. Rock has responses. Now you come to a word that many people associate with fear: earthquake. Tonight, you will unwrap it slowly, until it feels understandable and grounded. An earthquake is not an explosion, not a collapse, not a sudden creation of motion from nowhere. It is a release. Stress builds gradually in rocks along a fault as plates continue to move. But friction along the fault resists motion. The rocks lock together. Movement continues elsewhere, so stress accumulates like tension in a slowly twisted rubber band. For years, decades, sometimes centuries, the stress increases quietly. Nothing seems to happen. The ground appears calm. But deep below, energy is being stored elastically in bent and compressed rock. Then, when the stress exceeds the frictional strength, the fault slips. The rocks on either side shift, often just centimeters or meters, and the stored energy releases as seismic waves. These waves travel outward through the ground, carrying the vibration you might feel at the surface. It is not the motion of plates starting suddenly. It is the delayed adjustment finally occurring. Like a held breath letting go. After the slip, the rocks lock again, and the slow buildup resumes. Stress. Hold. Release. Reset. A cycle, not a chaos. Seismic waves move in different ways. Some compress and expand the ground in the direction they travel, like sound waves moving through air. Others move the ground side to side or up and down. Instruments called seismometers detect these motions with exquisite sensitivity, drawing weighty lines that scientists read like heartbeats of the planet. Each earthquake writes a brief signature, a pulse in the long rhythm of tectonics. Most are small. So small that only instruments notice. Thousands occur each day across the world without human awareness. The crust is constantly making micro-adjustments, like a settling structure softly ticking at night. You might find comfort in that motion is often released in tiny portions. The system prefers balance. Faults also leave visible marks over time. Streams may bend where they cross an active fault. Rock layers may be offset like misaligned stripes. Long scarps, small cliffs, can form where one side has lifted relative to the other. Geologists read these features like clues, reconstructing past movements. The landscape keeps records if you learn its script. There is also something called fault creep, a phrase that sounds eerie but is actually gentle. In some places, Faults slip very slowly and continuously without producing large earthquakes. The motion is steady enough that stress never accumulates to dangerous levels. The rocks slide past each other like glaciers, patient and quiet. Not every boundary snaps. Some prefer to glide. You rest with that thought. Earth has multiple ways to adjust. Sudden and gradual. Locked and creeping. Loud and silent. Nature rarely uses only one method. Even where earthquakes are stronger, they are still part of a broader balancing system. Without fault slip, stress would grow indefinitely, and the crust would not be able to accommodate plate motion. Release is necessary. Adjustment is healthy at planetary scale. Reframing changes feeling. You are not being asked to ignore risk in waking life. Preparedness matters, but here, in this quiet exploration, you are seeing the mechanism beneath the headline. Understanding replaces mystery. Process replaces fear. Cracks in rock are not signs of failure. They are signs of response. Every material has limits. Even steel bends. Even ice fractures. Earth's crust is strong, but not infinitely so. Its fractures are part of how it stays dynamic rather than locked forever. You gently widen your view again, from individual faults back to plate boundaries, from plate boundaries back to the moving shell of the planet. Lines, seams, edges, currents all connected in one slow system of stress and release. And as you follow these fracture lines across continents, you begin to notice that in some places, the crust is not only cracking and slipping, it is stretching, thinning, and slowly opening, as if a continent itself is beginning to let go. Tonight, you travel to places where the Earth is not colliding, not sliding, but gently opening. You stand, in imagination, on a wide continent under a calm sky. Nothing appears broken. Wind moves through grasses. Rivers follow their courses. But deep below, forces are at work that pull in opposite directions. The crust here is under tension, slowly, steadily being stretched. Not torn apart in a moment. Drawn apart across ages. This is where rifting begins. A rift is a region where the lithosphere, the rigid outer shell, is being pulled and thinned. You can picture a piece of warm bread dough held at both ends and gently stretched. It narrows in the middle first. Small cracks appear. The surface lowers slightly as material spreads outward. On continents, this stretching creates long depressions called rift valleys. You float above one now in your mind's eye. It runs like a scar that is also a cradle, steep sides, lower center, extending for hundreds or even thousands of kilometers. The valley floor sits dropped between faults, like a central block settling between two lifted shoulders. This central block is called a graben, though you don't need the term to feel the shape, a down-dropped corridor between parallel fractures. Rift valleys are not always barren. Some hold lakes that shine like mirrors. Some cradle farms and towns. Life continues while geology works slowly underneath. Change does not cancel beauty. Often it frames it. The stretching starts deep. Heat from the mantle rises closer to the surface here, weakening the overlying rock. Warmer rock bends more easily. As it warms and expands, it also becomes more buoyant, gently lifting the region. Then, as the crust thins and fractures, sections begin to sink between faults. You imagine the crust like a thick chocolate layer over warm caramel. If the caramel warms and shifts, the chocolate above develops long, branching cracks. From below, molten rock magma may rise through these fractures. Sometimes it cools underground as dark vertical sheets called dikes. Sometimes it reaches the surface as lava flows. Not always explosive. Often fluid, steady, spreading in sheets that cool into new crust. Rifting often travels with volcanism, but not always with violence. Many eruptions in rift zones are more like overflows than blasts, magma finding pathways upward through stretched stone. You notice a pattern forming again. When pressure is reduced, melting becomes easier. As crust thins, the weight pressing down decreases. Mantle material rising beneath experiences less pressure and can partially melt. This is called decompression melting, a calm phrase for a powerful idea. Less pressure, more freedom to melt. It is another gentle rule of physics shaping continents. One of the most beautiful active rift systems on Earth today is the East African Rift. You drift there now in imagination across savannas, lakes, and volcanic highlands. This rift stretches thousands of kilometers from the Afar region in the northeast down through eastern Africa. Satellite measurements show that parts of this region are slowly moving apart only millimeters each year, but measurably. The African plate itself is gradually dividing into two major pieces, the Nubian plate to the west and the Somali plate to the east. A continent beginning to separate. You might expect such a statement to feel alarming, but remember the tempo, millions of years. Mountains will erode, climates will shift, species will evolve, all while the rift continues its patient widening. In some segments, the Rift Valley holds long, deep lakes, Tanganyika, Malawi, Turkana, formed where the crust has dropped and water has gathered. These lakes are like blue threads stitched along the opening seam. Volcanoes rise nearby too: Kilimanjaro, Mount Kenya, Erta Ale, fed by magma linked to the stretching lithosphere and warm mantle below. Fire and water coexist along the same slow boundary. Rifting is not limited to continents. You have already visited divergent boundaries beneath oceans, mid-ocean ridges, where plates move apart and new crust forms continuously. Those underwater ridges are, in a sense, mature rifts, places where separation has progressed so far that an ocean basin already exists. Continental rifts are earlier chapters in that story. You can think of it as a three-stage journey. First, a continent domes upwards slightly as heat rises beneath it. Then it fractures and forms a rift valley. If stretching continues long enough, the crust thins until it breaks fully apart. Magma rises and solidifies between the separating sides, creating new oceanic crust. Water eventually fills the low space, and a new ocean is born. Rift Valley. Narrow sea. Wide ocean. The Atlantic Ocean began this way when an ancient supercontinent started to divide. What is now a vast ocean once began as a continental rift, a long, stretched scar that slowly widened and filled. Beginnings can be narrow. Not every rift succeeds. Some begin and then stall. The forces change. The stretching slows. Cooling strengthens the crust again. These are called failed rifts, geological attempts that did not continue to full separation. Even in failure, they leave marks, basins, faults, unusual rock patterns, clues to past tension. The Earth experiments patiently. You run your awareness along a rift valley wall in your imagination. Layered rocks are exposed like pages of a book. Each layer records an environment: river sediment, volcanic ash, ancient soil. Stretching and faulting tilt and offset these layers, making the history visible. Geologists read rifts like open archives. There is also a soothing symmetry to rifting. It is not only about breaking, it is also about making space. New crust forms. New basins collect water and sediment. New ecological niches appear. Separation creates opportunity. Opening is creative. You may notice how different this feels from the word crack you visited in the last chapter. A crack suggests sudden breakage. A rift is more like a long exhale, extended, progressive, structural. Not a snap, but a stretch. Even where earthquakes occur in rift zones, they are part of the adjustment to extension: blocks settling, faults slipping, tension redistributing. The system seeks a new balance as it widens. You rest with a wide view now: continents not as fixed continents, but as temporary gatherings of crust that can merge and separate across deep time. Today's map is not permanent. It is a frame in a very long film. The ground beneath future generations may belong to different neighbors across water not yet formed. And that raises a gentle, intriguing question: how do scientists read the early signs of these openings, and what subtle clues in rock and magnetism reveal where stretching is truly underway? Tonight, you become a reader. Not of books made from paper and ink, but of books made from stone and silence. You step into the role of a patient listener, someone who knows that the earth keeps records not in sentences, but in patterns. Not in paragraphs, but in layers. Rocks remember. You hold that idea softly as you begin. Every rock forms under certain conditions: temperature, pressure, chemistry, environment. Those conditions leave signatures inside the minerals, like fingerprints pressed into crystal. With careful tools and gentle reasoning, scientists learn to read those signatures and reconstruct stories that stretch far beyond human memory. You are not rushing through this archive. You walk the aisles slowly. You begin with layers. Sedimentary rocks form in sheets, grains settling in water, dust gathering in air, shells accumulating on ancient seafloors. Over time, these sediments compress and harden into stone. Each layer represents an interval: a season, a millennium, sometimes longer. Stacked together, they form timelines you can see with your eyes. A cliff face becomes a vertical calendar. If layers lie flat and undisturbed, they speak of calm deposition. If they are tilted, folded, or broken, they speak of later motion: uplift, compression, faulting. Structure becomes language. Geometry becomes grammar. You trace tilted layers in your imagination and understand: this land did not always sit the way it sits now. Something moved it after it formed. That something is often plate motion. Now you move to a different kind of memory: magnetic memory. This one feels almost magical, but it is grounded in physics. Some minerals, especially those containing iron, behave like tiny compass needles when they form from molten rock. As lava cools, these minerals align with Earth's magnetic field at that moment. Once locked in place, they preserve that direction. A frozen pointing. Earth's magnetic field is not constant across all time. It flips. North becomes south, south becomes north. These reversals happen irregularly, sometimes after hundreds of thousands of years, sometimes longer. When they occur, new rocks forming at that time record the new orientation. Now you return in imagination to the ocean floor, to the long mid-ocean ridges where new crust is created. Lava rises, cools, and locks in the current magnetic direction. As seafloor spreading continues, that rock moves outward from the ridge, making room for newer rock behind it. The result is astonishingly orderly. Parallel magnetic stripes form on both sides of the ridge, bands of normal polarity and reverse polarity, mirrored across the centerline. A barcode written in basalt. A symmetrical record of spreading through time. You float above this striped seafloor in your mind, dark rock carrying invisible magnetic bands, each one a timestamp of planetary magnetism and crust creation. This discovery was one of the great confirmations of plate tectonics. Not theory alone. Not matching coastlines alone. But measurable, repeating, global pattern. The planet signing its process. You move next to another kind of clock, radioactive clocks inside minerals. Some elements naturally change into other elements at steady, known rates. Uranium slowly becomes lead. Potassium becomes argon. These transformations happen with reliable timing, like hourglasses that cannot be hurried or slowed. When certain minerals crystallize, they trap the parent element inside their structure. Over time, the daughter element accumulates. By measuring the ratio between them, scientists can calculate how long the mineral has existed since it formed. This is called radiometric dating, but tonight you can think of it simply as crystal timekeeping. Tiny atomic clocks embedded in stone. With these clocks, the ages of rocks can be measured in millions or billions of years. Oceanic crust shows young ages that increase with distance from mid-ocean ridges. Continental rocks reveal much older histories, some over 4 billion years old. Age patterns match motion patterns. Distance matches time. The map and the clock agree. Agreement is one of science's most soothing qualities. You continue walking through this archive and come to fossils not as curiosities, but as coordinates. Certain fossils are known to have lived only during specific geological intervals. When they appear in rock layers, they help date and correlate those layers across regions. Index fossils, they are called, but you can imagine them as biological timestamps. Life forms that briefly flourished, then vanished, leaving recognizable shapes behind. When identical fossils appear on continents now far apart, they suggest former connection. You visited this clue earlier. Now you see how it fits into a broader toolkit of reading methods. No single clue stands alone. Science prefers choirs to soloists. There are also clues in chemistry. The ratios of certain isotopes reveal the temperatures at which minerals formed. Trace elements indicate source regions deep in the mantle. Even tiny bubbles trapped in crystals, fluid inclusions, preserve samples of ancient liquids and gases. Rocks are not mute. They are densely annotated. You visit the tools that help scientists read these messages. Mass spectrometers measure isotopes with extraordinary precision. Magnetometers detect faint magnetic signals in stone. Seismic instruments map structures deep underground using wave behavior. Satellites measure plate motion directly using GPS, tracking continental drift down to millimeters per year. Instruments extend the senses like calm mechanical companions, helping human curiosity reach farther. You might notice how gentle this whole process is. No shouting at nature. No forcing answers. Just careful measurement, repeated observation, patient interpretation. Science here feels less like conquest and more like listening. Listening takes time. But time is exactly what geology has. You kneel, in imagination, beside an outcrop, a place where rock layers are exposed at the surface. You run your fingers across textures, coarse grains, fine laminations, crystal faces catching faint light. Each surface is a page. Each mineral a letter. You do not need to read it fluently to feel its meaning. This world has a memory, and it is accessible. That thought can be deeply comforting. You live on a planet that is not random, not chaotic, but recorded. Processes leave traces. Motion leaves signatures. Change leaves structure. Predictability grows from preserved pattern. And that naturally leads your thoughts forward. If rocks record past motion so faithfully, then perhaps those same measurements and patterns can help scientists estimate how plates will continue to move in the future, and where the next great changes may slowly begin. Tonight, you imagine the world as both vast and precise, moving at a pace almost too slow to notice. You are still resting on the lithosphere, that floating shell you have traveled across, but now your attention turns to understanding its future. How can someone predict motion that is measured in centimeters per year? How can you forecast what takes millions of years to unfold? The answer is patience. Patience, instruments, and careful observation. You begin by imagining a single point on a plate, perhaps the bedrock beneath your imagined feet. You mark it in your mind with a gentle awareness. That point, like a quiet traveler, moves imperceptibly each year. Only a few centimeters smaller than a fingernail's growth, but it moves, consistently, persistently. This is plate motion, steady, relentless, unhurried. Scientists measure this with tools that require incredible precision. GPS satellites orbit above, beaming signals down. Tiny shifts in these signals reveal movements of land with millimeter accuracy. Over months and years, these measurements accumulate into patterns. Continents are not static, not fixed. They are travelers on a slow, predictable journey. You imagine the satellites quietly floating above, keeping vigil, like calm watchful eyes. They track the plate beneath you, whispering its movements to earth-bound instruments. Through these whispers, you begin to perceive trajectories, the direction of drift, the speed of motion, the interaction with neighboring plates. Patterns emerge. A line of mountains grows slightly higher each year. A valley broadens imperceptibly. The ocean floor spreads as magma steadily rises at ridges. These motions are so slow that life scarcely notices. Yet, over millions of years, the incremental shifts become monumental. Entire oceans open, continents separate, mountains rise and erode, climates change, all while measured in tiny steps. You sense the paradox: the smaller the motion, the more profound the long-term effect. Forecasting this motion is not about certainty. It is about probability and range. Scientists create models based on past behavior. They look at the rate of spreading at ridges, the frequency and direction of subduction, the alignment of faults, and the accumulation of stress. They combine satellite data, GPS measurements, and geological history. From this, they make predictions: this plate will move toward that plate. This rift may widen. This subduction zone may deepen. These forecasts are gentle maps of possibility, not absolute declarations. Time stretches into deep intervals. Patterns take millions of years to become obvious. The future is vast, slow, and patient, like the rhythm of breathing Earth itself. Even the smallest indicators hold significance. A tiny shift along a fault, a subtle change in gravity measured from space, a variation in magnetic stripes on the seafloor, these are whispers from the planet, hinting at the direction of future movement. Attention to detail transforms uncertainty into informed understanding. The more carefully we listen, the clearer the story becomes. You drift across a virtual globe in your mind, tracing the edges of plates, noting where interactions are strongest. Some zones are calm, some are stressed. Divergent boundaries expand steadily. Convergent boundaries push and buckle. Transform boundaries slide past each other in quiet tension. Each movement has a rhythm, a signature, a predictable element when seen through long-term observation. And yet, you understand that nature always holds subtle surprises. Earth does not perform on a clock. Sudden shifts, volcanic pulses, or larger earthquakes punctuate the slow drift, reminding you that forecasting is an art of probabilities, not certainties. But even in these surprises, the underlying rhythm persists: the deep engine of mantle convection, the slow dance of plates, the constant redistribution of stress. You can imagine your role as a patient observer. You do not need to rush. You do not need to predict each event precisely. Instead, you notice trends, patterns, and probabilities. You track small changes, understand the forces at play, and anticipate gradual shifts. This is forecasting in a slow world. There is a poetic comfort in this rhythm. You realize that just as you plan your own life in steps and stages, Earth plans its own evolution in gentle, measured increments. Mountains will rise, seas will widen, rifts will lengthen, all in their own deliberate time. You and the planet are both participants in processes that unfold gradually, with patience, persistence, and subtle guidance. As you float above the plate boundaries again, you notice the slow movement of the ocean floor, the gentle spreading at ridges, the quiet sinking at subduction zones. You see the faint outlines of future mountain ranges, future valleys, and the possibilities of new oceans. Each step in the present is a building block for the distant future, a small but essential contribution to the ongoing evolution of the planet. You reflect on how long-term forecasting requires trust in the subtle signals, in instruments and measurements, and in the persistence of natural laws. Patience, attention, and understanding create foresight. The slow world teaches you to value small, steady movements and to honor the accumulated wisdom they carry. Even the faintest motions can foreshadow monumental change. A few millimeters per year, repeated over millions of years, produce landscapes that dwarf human comprehension. Continents drift across oceans. New oceans form. Mountains rise. Rift valleys lengthen. These motions are gentle, gradual, and yet ultimately transformative. You allow yourself to sink into this perspective. Motion and stability coexist. Even as the ground beneath you moves, you are safe, supported, and part of a rhythm that stretches across deep time. The planet moves with quiet elegance, and the instruments of science allow us to witness and understand that rhythm without rushing it. And as you gaze toward the subtle, continuous motion of plates, you begin to wonder softly, if scientists can measure the past and present with such patience, how do they anticipate the future regions of change, the next rifts, the new valleys, the slowly opening doors of continents yet to come? Tonight, you drift across the surface of a planet that is quietly alive, not in sudden bursts, but in slow, deliberate unfolding. You are returning to the theme of rifting, but now with a sharper eye toward real places where new continental separations may eventually take form. The Earth is patient and yet persistent. Change is happening, though so gradually that a single human lifetime may barely register it. Your journey begins in Africa, along the East African Rift. This vast zone stretches over thousands of kilometers, from the Afar Triangle in the northeast down through Ethiopia, Kenya, Tanzania, and beyond. The land here is subtly stretching. Satellite measurements show the African plate slowly dividing into the Nubian plate to the west and the Somali plate to the east. Only a few millimeters each year, almost imperceptible, yet this persistent motion is reshaping the continent over millions of years. You float above the rift in imagination. The terrain below is a tapestry of valleys, volcanoes, and lakes. The Rift Valley itself is wide and deep, flanked by rising mountains and dotted with volcanic cones that occasionally release molten rock from the warm mantle below. Lakes Tanganyika, Malawi, and Turkana shimmer like mirrors within the lowered blocks of crust. Here, the land is being gently stretched, slowly creating room for a new ocean that will not appear for millions of years. Further away, your attention shifts to the oceans. Mid-ocean ridges like the Mid-Atlantic Ridge are mature rift systems, where crust is already being created as plates pull apart beneath the sea. Here, new ocean floor is continuously born as magma rises and cools, pushing older crust outward. These ridges trace long, twisting seams across the globe, hidden from sight but endlessly active. You can picture the ocean floor slowly widening, centimeter by centimeter, a subtle yet unstoppable motion that shapes continents over geological time. But there are more subtle and hidden zones, two areas where the crust is thinner, weaker, or fractured in ways that may eventually give rise to new rifts. These are the blind corners of the planet, quiet places where motion is concentrated deep below, but where visible change has yet to fully manifest at the surface. Geologists detect them through careful measurements, slight tilting of land, minor earthquake clusters, variations in gravity, and heat rising from the mantle. Each clue hints at the long-term possibility of crustal separation. One such area is the Baikal Rift Zone in Siberia, the deepest continental rift on Earth. It is slow, subtle, almost imperceptible, yet it is gradually pulling the crust apart. Lake Baikal sits within this rift, deep and narrow, holding water that has accumulated over tens of millions of years. The surrounding landscape is dotted with volcanoes and faults, silent witnesses to the patient work of geological forces beneath. As you imagine drifting over these regions, you notice how time frames shift. A year may yield a few millimeters of motion. A century may give a few centimeters. But over millions of years, the cumulative change is breathtaking. Valleys widen, mountains rise, oceans grow, and continents move apart. The Earth's scale of patience dwarfs human perception, yet it is as precise as a clock when measured with instruments and interpreted by careful observation. You pause for a moment above the Red Sea. Here, a narrow corridor of water already exists where Africa and Arabia are separating. You can picture the crust stretching gently, slowly, day by day, inch by inch. The Arabian plate drifts away from Africa, forming new space for oceanic crust to emerge. In the distant future, the Red Sea will widen, and the rift will resemble the mid-ocean ridges you imagined earlier. Possibility, not certainty, guides your vision. You notice that the Earth's creativity is both deliberate and subtle. Rifting does not happen everywhere at once. It concentrates along zones of weakness, guided by mantle flow, thermal anomalies, and the existing fractures in the lithosphere. The patterns are complex, branching, irregular, yet they are not chaotic. Underlying physics, heat, pressure, and material properties shape the motion with quiet order. Volcanic activity is often a companion to rifting. In the East African Rift, volcanoes such as Mount Kenya, Mount Kilimanjaro, and Erta Ale punctuate the landscape. Their eruptions are mostly gentle flows, not explosions, allowing the crust to slowly adjust. Magma rising into the stretched crust adds new material, creating gentle uplifts and further weakening the lithosphere. The interplay of tension, heat, and material movement orchestrates the formation of future ocean basins. You also drift over the Afar Triangle, where three tectonic plates converge: the Nubian, Somali, and Arabian plates. Here, rifting is happening in three directions simultaneously, creating a unique, complex pattern of fractures and valleys. You can imagine the land slowly splitting, forming a triangular zone that may eventually give birth to a new sea, with volcanoes and valleys as its first features. The process is patient, measured in millions of years, yet undeniably underway. Even in places without dramatic surface features, subtle signs of future rifts are present. Slight earthquakes, changes in elevation, heat fluxes, and geochemical anomalies all whisper the possibility of motion. Geologists read these signs like a quiet language, translating imperceptible shifts into a long-term vision of Earth's evolution. The surface may appear calm, but deep below, the engine of change continues its slow, steady work. As you continue your mental journey, you see that the planet is constantly in motion, and that new rifts are both rare and inevitable. Rare because specific conditions must align, the crust must thin, the mantle must provide support and heat, and existing weaknesses must guide the stretching. Inevitable because Earth's interior heat, convection currents, and plate dynamics ensure that motion continues somewhere, always. The notion of scale comforts you. Even the fastest rifts move at mere centimeters per year, imperceptible in the span of a human life, yet monumental over geological time. Valleys deepen, mountains rise, lakes form and evaporate, and oceans slowly widen. The Earth's timeline is vast, patient, and rhythmical. You can witness these processes in your mind, sensing them as continuous and interconnected flows of energy and matter. Rifting is a story of beginnings. From the first cracks and faults to the widening valleys and emerging volcanoes, a new chapter in Earth's geography unfolds. Possibility replaces certainty. Even if a rift fails to develop fully, it leaves traces, scars, basins, and altered landscapes that mark the planet's long memory. Failure and success are part of the same patient rhythm. As you slowly rise above these imagined landscapes, you notice the interconnectedness. East Africa, the Red Sea, mid-ocean ridges, hidden weak zones, all parts of a single system. Plates move, mantle currents flow, and the lithosphere responds. patterns of stretching, uplift, and magma ascent recur across continents and oceans, revealing the planet's subtle choreography. You sense that rifting is a gentle force of renewal. It does not destroy, it reshapes. It creates space, opens valleys, fosters new habitats, and lays the groundwork for future oceans. The Earth's slow unfolding teaches patience, resilience, and the beauty of gradual transformation. And as your awareness drifts over these regions, a soft, compelling question arises: if the Earth is already preparing new landscapes, what clues in rocks, faults, and magnetic stripes might reveal exactly where the next great rift will take hold, opening doorways for continents and oceans yet to come? Tonight, you float above the present and let your mind drift into the vast corridors of deep time. The continents beneath you are no longer just landmasses with familiar shapes and names. They are travelers on a journey of patience, gliding slowly over the viscous mantle below. Every mountain, every valley, every ocean basin is part of a story that stretches across millions of years, unfolding at a rhythm both subtle and inevitable. You start by observing the plates themselves. They move at rates so slow that a single human lifetime is barely a blink, mere centimeters per year. Yet over tens, hundreds, or millions of millennia, these motions accumulate. The shapes of continents, the positions of oceans, and the outlines of mountain chains are all the product of patient motion. Each plate is like a dancer tracing gentle arcs across the stage of the planet, and you, a quiet witness, see the choreography with awe. As you drift over Africa, you notice the East African rift stretching wider, its valleys deepening gradually. In your mind, you follow the plates inching apart. What is now a series of rift valleys may one day become a narrow sea. The Red Sea continues to widen. Slowly, the Somali plate drifts eastward, while the Nubian plate moves west. The landscape is reshaped not abruptly, but with deliberate, measured motion. This is the essence of deep time. Change is inevitable, but it is patient. You let your gaze travel across the Atlantic Ocean. Even now, the Mid-Atlantic Ridge continues its quiet work, pushing North and South America farther from Europe and Africa. Imagine the continents drifting as if on invisible conveyor belts. The slow opening of ocean basins, the gradual rise of underwater mountains, and the constant recycling of crust at subduction zones form a rhythm that has persisted for billions of years. You see history and future merging into one continuous process. As the continents move, they interact in new ways. Collisions will occur, creating mountains yet to rise. Rifts will open, forming oceans that do not yet exist. Islands will emerge from the sea, shaped by the slow addition of volcanic crust. The landscape is fluid, yet deliberate, sculpted by forces too large and slow to notice day by day, yet precise over eons. You sense that the Earth is neither chaotic nor static. It is a patient, methodical artist, shaping its surface with long-term foresight embedded in physics and mantle flow. You drift toward the future of the Pacific. Imagine its boundaries hundreds of millions of years from now. Subduction zones continue to consume oceanic crust. Island arcs may merge, forming new continents. The Pacific Basin may shrink as surrounding plates converge. Ocean ridges continue to create crust, extending basins and separating plates in a pattern that repeats across the globe. The dance of plates is ongoing, unhurried, eternal. Time becomes expansive as you watch. Millions of years stretch beneath your awareness. Mountains rise and erode, sediments accumulate in basins, rivers carve new paths, and glaciers sculpt the land. Life continues to respond, adapt, and flourish in the spaces opened by this slow motion. Every inch of movement, every shift in the crust, contributes to a dynamic equilibrium. The Earth is both stable and in motion, comforting in its constancy and patient in its evolution. You imagine what supercontinents may form. In deep time, the continents of today may converge once again, as they have in the past, forming vast landmasses that span entire hemispheres. Yet even as they come together, new rifts begin to appear elsewhere. The cycle of assembly and breakup repeats, a slow heartbeat measured over hundreds of millions of years. This is deep time, a rhythm that is beyond urgency, beyond human perception, yet profoundly ordered. Beneath your mental feet, the mantle flows like a viscous ocean, moving the plates above it. Convection currents rise and fall, carrying heat and material across thousands of kilometers. The crust floats upon this dynamic layer, pushed and pulled in subtle ways that cumulatively shape the surface of the Earth. You sense the connection between deep forces and surface forms. Nothing is isolated, nothing is instantaneous, and everything is part of an integrated system. As you drift above future landscapes, imagine continents reshaping slowly. Africa, Eurasia, the Americas, Australia, and Antarctica, each moving along its path, tracing arcs across the globe. Coastal lines change. Mountain ranges form and erode. Ocean currents respond to new configurations. Climate shifts, slowly, over centuries and millennia. You observe patterns repeating, over and over, but never exactly the same, nature's gentle improvisation on a grand scale. You realize that human perception is brief in comparison to this slow motion. What seems solid, permanent, or fixed is only a momentary snapshot. Yet this very slowness brings comfort. Change is not sudden, threatening, or uncontrollable. The Earth moves with a deliberate cadence, and you, as a witness, can feel its gentle rhythm and trust its enduring stability. In this vision, you also recognize the inevitability of renewal. Oceans will open, mountains will rise, valleys will deepen, and continents will separate and collide again. Earth's memory is preserved in rocks, sediments, and magnetic stripes. The planet's future is a tapestry woven from the same threads that shaped its past. Every process is gradual, continuous, and measured, a quiet unfolding that invites observation rather than alarm. You take a moment to reflect on continuity. The same forces that created familiar landscapes now continue to operate in the distant future. Rifting, subduction, spreading, faulting, erosion, all are ongoing, unhurried, essential. The Earth maintains its balance through these processes, demonstrating resilience across deep time. You sense the patient intelligence of a planet that has endured billions of years and will continue to endure for billions more. As your gaze stretches over imagined future continents, you notice the interplay of creation and destruction. Mountains rise where plates collide, valleys and rift zones form where plates separate. Magma fills gaps. Erosion smooths peaks. Rivers and glaciers sculpt. The land is constantly reshaped, yet always stable enough to support life. The planet's motion is neither random nor violent. It is a careful, patient orchestration. Finally, you allow yourself to drift in contemplation. You imagine Earth hundreds of millions of years from now, its continents still moving, its oceans still flowing, its mountains and valleys rising and falling in a slow, continuous rhythm. Time is spacious and calming, stretching across epochs like a river that never rushes. You feel the enduring patience of the planet, the unhurried choreography of crust and mantle, heat and pressure, rise and fall. And as you hover in this vast, slow-moving world, a gentle question lingers in your mind: if continents are ever-shifting travelers in deep time, patiently shaping the face of the earth, how will the land beneath our feet continue to evolve in ways we can barely perceive today, leaving clues and whispers for future observers to read? Tonight, you come back to the present. After journeys across rift valleys, spreading ocean floors, and imagined futures, your awareness settles once again on the familiar ground beneath you. Yet this ground is no longer inert. It is not a still, unchanging stage. You feel it subtly alive, traveling slowly across the face of the planet, a steady rhythm beneath your feet. The lithosphere, that floating shell you have come to know, continues its patient motion. Plates slide, collide, and separate with calm inevitability. You sense the weight of this movement without fear, feeling instead the gentle reassurance that the Earth's processes are deliberate and balanced. It is as if the planet itself breathes, inhaling heat from the deep interior, exhaling motion at the surface. You rest atop a living world. You notice the textures of the crust beneath you, solid, supportive, yet subtly dynamic. Mountains rise and erode, rivers carve valleys, and oceans creep across the globe. You understand that this is not chaos, but harmony unfolding over time. Motion is not disturbance. It is the pulse of a patient, enduring system. Rocks fracture, faults slip, and rifts open, all in small increments that accumulate into the landscapes we recognize. Every process is gradual, measured, precise. You imagine the continents gently drifting, moving with imperceptible grace. Africa slowly separates from Arabia. The Americas glide westward, nudged by mid-ocean ridges and subduction zones. Plates that today seem immovable are in fact travelers across the mantle, carrying mountains, rivers, forests, and life itself on their patient journey. This realization brings a comforting sense of continuity. The Earth is neither static nor chaotic, but always progressing with purpose. As your awareness expands, you reflect on the cycles you have explored. The formation of mountains, the rise of rift valleys, the spreading of ocean floors, all are interconnected. Stress builds along faults and releases gently. Magma rises and solidifies. Sediments accumulate and preserve memory. The planet's processes operate in rhythm, each action influencing the next. You begin to see motion not as unpredictable, but as a story told in increments, a narrative you can read through observation and imagination. You feel the steady presence of time, stretching outward in waves both past and future. The Earth's memory is vast, it holds clues to what has been and hints of what may come. Rocks, fossils, magnetic stripes, and sediments form a quiet archive, patiently documenting motion and change. You recognize the beauty in this patience. Time is generous, allowing processes to unfold gently, teaching endurance and perspective. You can rest in this awareness, letting it soothe your mind. Breathing slowly, you bring your attention to the interplay of forces beneath your feet. Convection currents in the mantle rise and fall, plates are nudged and guided, and heat from the interior circulates quietly. Earthquakes, volcanic eruptions, and rifting are not abrupt surprises but natural adjustments to these deep-seated motions. Each event, whether subtle or dramatic, contributes to a dynamic balance that sustains the surface you inhabit. You notice that understanding this rhythm transforms perception. Motion that once seemed alarming becomes predictable, almost musical. Each tectonic process has a tempo, the grinding of faults, the expansion of rifts, the rise of magma, all are part of the Earth's patient choreography. In this stillness, you reflect on the fragility and resilience of landscapes. Mountains erode, valleys deepen, and oceans shift, yet the planet endures. Life adapts to these changes, landscapes evolve, and ecosystems respond to slow but continuous motion. You let your mind drift over the continents, imagining their paths across millions of years, aware that even the familiar shapes beneath you are temporary. Coastlines will reshape, oceans will widen, and mountains will rise anew. The knowledge of deep time offers both perspective and serenity. Change is constant, yet measured. You and all life are supported by this rhythm, carried forward across space and time by a planet that moves with intention and poise. Your senses expand to include the quiet signals of the planet. The faint vibrations of distant earthquakes, the slow spreading of mid-ocean ridges, and the subtle rise of rift valleys all form a gentle symphony. Even these natural movements, imperceptible in the short term, harmonize over millions of years, sustaining the continuous reshaping of the Earth. You rest in this awareness, letting the planet's own rhythm lull your thoughts into calm observation. You reflect on how observation and curiosity are connected. Scientists measure, record, and interpret these motions not to control them but to understand them. Instruments extend human perception, satellites measure minute shifts, and careful study reveals patterns across the globe. You feel part of this continuum, an observer of a story written in stone, water, and time, a witness to the slow unfolding of creation and transformation. In this space of calm reflection, the distinction between present and future begins to blur. You are simultaneously here, atop the moving crust, and far into deep time, watching continents shift, oceans open, and landscapes evolve. There is continuity, rhythm, and patient logic. Motion becomes nurturing rather than threatening, a reminder of the Earth's stability within its own patterns. Finally, you allow yourself to settle fully into the present moment. You feel supported, carried by a moving world that is not rigid but alive, not hurried but deliberate. Every shift beneath your feet, every distant earthquake, every slowly rising rift is part of a larger orchestration. Motion is not chaos, it is companionship, a steady reminder that change is natural, inevitable, and beautiful. You close your mental journey with one last gentle reflection: the continents, oceans, and mountains will continue to move and reshape, long after individual lives have passed, and you rest in the quiet trust that this traveling world carries you forward with patience, grace, and endless wonder. And as you drift into sleep, a final thought lingers softly, like a whisper: if the Earth moves with such calm certainty across eons, what new landscapes, valleys, and oceans will quietly await the gaze of those who come after us?